Okay, now we proceed to example 20. Okay, so in this question, okay, it's given follow a normal distribution. Okay, so that means we have a normal distribution with the mean 10. Okay, so we have the mu 10 and we have a variance of 4. We have the variance of 4. So the question asks is the probability that a measurement will exceed 13. Okay, so for question A, we have probability of x greater than 13. Okay, so we must standardize the normal distribution. That means we must have the z. So we have this one greater, so it's greater. And the formula of standardized normal distribution is x minus mean. So we have x is 13 minus our mean is 10 and over the standard deviation. So this one is the variance. Okay, so the variance is equal to 4. That means the standard deviation is the square root of the variance is equal to 2. So we have probability of z greater than 1.5. Okay, now z greater than 1.5, that means we have the greater. So we can get the answer from the normal distribution table. Okay, so this is the distribution table. So we want to look for z greater than 1.5. So this is 1.5. Okay, it's here. So 1.5 is 0.0668. So it's equal to 0.0668. Okay, now we look at the question number B. What is the probability that the measurement will be between 9 and 11? That means your S is between 9 and also 11. So you must standardize the normal distribution. So that means the Z is here. Okay, we have X, standardize, then we get Z. So we have 9, our X minus our mu. Our mu is 10. And again, our standard deviation is 2. And 11 minus 10 over 2. Then we have the probability negative 0.5 Z and 0.5. Okay, so for this one, we have to use the formula. Okay, so this one is equal to, okay, we have the modulus of Z less than 0.5. Okay, so if we look at this, modulus and less than, okay, 0.5 is equal to 1 minus 2p, z greater than 0.5. So is equal to 1 minus 2p, z greater than 0.5. Now we have z greater than 0.5, so we can get this answer from the table. Z greater than 0.5. Okay, so 0.5 is here. Okay, this is 0.5. So x greater than 0.5 is 0.3085. Okay. Okay, so equal to 2 times with 0.3085. Okay, is equal to 1 minus 0.617. So it's equal to 0.383. Okay, now we look at the next example. Okay, so we have the exam marks, okay, with the mu, that's mean your mean is equal to 50 and your variance is equal to 16. So exam marks for the 20 student, that means you have n equal to 100. So find the number of students that pass the exam. So to pass the exam is equal to 40. So that means we must find the probability of student pass the exam. That means get the marks greater or equal to 40. Okay, so what is the probability? Okay, now, so this is the normally distributed. So that means we have the n, our mu is 50 and our variance is 16. So the probability when your x greater equal to 14 is equal to, okay, so we have to calculate the probability when x greater equal to 14. That means we have the z, okay, then our x is 14, our mu is 15, okay, this is our mu, over the standard deviation, our variance is 16. So we have the variance is 16, so that means our standard deviation is the square root of 16 is equal to 4. So if we solve this, we get z greater equal to negative 2.5. So we have greater and equal, but we have the negative. So we know is equal to 1 minus probability of z greater than 2.5. So 2.5, we can get this answer from the table. So we get 0.0062. So we get the answer is 9938.